SegWit. Yeah, and we saw how to unlock outputs that are locked by the script pub. So right now we'll be looking at the native SegWit, that is witness pub key hash. So I've already generated one's native SegWit address, so I'll just generate another. Yeah, it's batch 32. That is for SegWit. For native SegWit, that is. So this is the second address that we'll be using to send the coins. So this is the previous transaction. Yeah, so let us just create another transaction to this address. So the coins are from this address, determining the output script, to this address, determining the so this address will determine the input script. So yeah, send to address. Yeah, so I'll just put the address. Of course, it will fail because of insufficient funds. Let me just get the balance and be sure that I'm using the correct balance. So now I'll use the correct balance. And subtract the fee from it. So now this will be the current transaction ID. This is the current transaction, as you can see. So as always, we know that this current transaction will be spending the UTXO from this transaction. So this will be an out point of this transaction. Let us just confirm that it is so. So I'll just copy this address and use it over here. I'll just use it over here, and you'll see that this one has an input that is an out point to this transaction ending with 67. Yeah, so because this is a native SegWit, the script sig is empty. So one of the processes is like done. So now we're just looking at the transaction input witness, which has the signature and the public key, as you can see. Yeah, so this is the current transaction, this one. So now let us look at the previous transaction. So the previous transaction is determining the output script that we will be using. So this is determining the output script that we'll be using because it's a native SegWit. So the script pub key is very simple, as you can see, just the op0 and this hash over here. Yeah, so we will now go ahead and simulate it. So the bottom transaction is for the previous, the upper transaction is for the current. So for the upper transaction, we will just get the input, and then for the other transaction, we'll just get the output to be satisfied by our input script. So let us move to our simulator. So this is the native SegWit. So we have been using hashlib for everything. Yeah, for these hashes. So right now we'll just include the witness and the the witness data, which is the signature and the public key from our transaction. So this is from our current transaction, the transaction that is spending the UTXO from the previous one. So I'll just take the two information. So this is the signature, and this is the public key. Okay, so you can observe the public key for this one starts with 02, so it means that it is a positive one. So now this is the upper transaction where we're just taking the inputs, and then for the lower transaction we are taking the outputs. So the output script for this one is a bit simple. It is very simplified. It is just this and this one. So this is what we want to satisfy. So I'll just check this. So this is SegWit version 0 again. So now the expected public hash, public key hash from this. So now we are just done. It's a bit simple as compared to the wrapped one. Yeah, because with this one you can see that the input, we're just looking at the witness data and this one over here. So the first step that we'll do, we'll create the breakpoint again over here and run in debug mode. Okay, so the first thing that we are doing, we are initializing the witness and putting the expected pub key hash, which should be 20 bytes. Let me just confirm if it is 20 bytes. Yeah, it is 20 bytes. So we'll continue with the debug mode. So step 1, we are pushing the signature. The first one is the witness data. And printing the stack, we can see we have pushed the signature. And now we are pushing the public key. Printing the stack, we can now see the signature, the public key and the signature. And then we are duplicating the public key. Yeah, and now we have duplicated the public key. And now we want to hash we want to pop the public key and then hash it. Yeah, now we have popped it, hashed it, and pushed it again. And now we are pushing the expected public key. This is from the pub key hash of the UTXO that we are spending from the current transaction. And now printing the stack, we can see now we want to check if they are equal. And yeah, so succeeded, so they are equal. And now what is remaining is just to the check sig. So this one is simpler than the other one because for the current transaction, the previous transaction is just providing the pub key hash, and then the previous transaction is just providing the public key that we are using, hashing it against the hash 160 algorithm. So yeah, so that's it. It is simple as compared to the wrapped one. Yeah, the main reason is because we have broken down this process, so this process is not available because we don't have the redeem script for this one as compared to the wrapped one, which had the redeem script. So we had to first check the redeem script and then check the witness. For this one, we're just checking the witness data. So this is the native SegWit. So yeah, that's it.